All right, so you want to understand the OSI model? Well, buckle up, because we're diving deep. We've got your articles right here, all ready to break it down for you.
It's kind of like peeking behind the curtain of the internet.
Right, seeing how it all works. And even though OSI isn't like the model running the show today, it's super helpful for understanding networking as a whole.
Yeah, think of it like the foundation for all those emails and videos you send and watch every day.
Okay, so let's rewind the clock a bit. Back to the 70s and 80s, the wild west of computers. Back then,
Yeah.
different systems were popping up all over.
And they had no idea how to talk to each other. It was a real mess. Like everyone speaking different
This
languages.
total Tower of Babel.
Ooh.
So how do we fix that?
Well, networks back then, like ARPANET, TCP/IP, they were showing their limits. So the OSI model came along to bring some order.
And it all became official in 1984. Talk about a big year.
Boom.
So how did they actually build this universal language for computers?
They broke it down into 7 separate layers.
7. Okay, you've got my attention.
Each layer has its own job, and they work together to move data from one device to another.
Okay, I'm intrigued. But before we unpack each layer, why does the OSI model even matter today? I mean, if it's not the main model in use, why bother?
You know, even though we don't use Roman numerals every day, understanding them helps us understand history, math, even design. Same with OSI.
Right, it's like the building blocks, even if the tech has moved on. So how did the OSI model actually impact things out in the real world?
Oh, it's had a huge impact. For one, it's super useful for troubleshooting. Like, say a website won't load.
Okay, I've been there. How would the OSI model help me fix that?
Well, you start with the physical layer. That's like checking your cables, Wi-Fi signal, all the physical stuff. Is your Ethernet cable even plugged in?
Okay, so start with the basics, make sure the foundation is solid. What if all the physical connections look good?
Then you move up to the data link layer. Here, you're looking at things like MC addresses. They're like unique IDs for each device on your network. If those aren't set up right, data won't go where it needs to.
So it's making sure the data goes to the right place on the network. What if the MC addresses are fine, but the website still won't load?
Then it's time for the network layer. This is where routing happens, figuring out the best path for data to travel across different networks. It's like a GPS for data packets.
So it's checking if there's any roadblocks on the data's journey. All right, let's say the network layer is all clear. Where do we go next on our OSI detective mission?
We hit the transport layer. This one makes sure data gets delivered reliably between applications. This is where protocols like TCP and UDP come in. TCP is like a certified letter with tracking. It makes sure everything arrives in order and without errors. UDP is more like sending a postcard. It's faster, but no guarantees it'll get there.
So TCP is for when you absolutely need that data to get there safe and sound. And UDP is for like streaming videos where a little glitch here and there isn't a deal breaker. So if my website's not loading, I'd want to look at TCP, right?
Exactly. If there's a problem with how TCP is configured, that could be blocking the website.
All right, so we've checked the physical connections, the addressing, the routing, and the delivery protocols. What if everything looks good so far? Where does OSI take us next?
We move up to the session layer. This one manages the whole conversation between devices, making sure the connection is set up, managed, and closed properly.
So it's like making sure the phone line's working before we start chatting. What about the presentation layer?
That layer makes sure the data is presentable to the application, handling stuff like data translation, encryption, and compression.
Okay, like making sure we're both speaking the same language before we start talking. And finally, the application layer. That's where we, the users, interact with the network, right?
Right on. It's where your web browser, your email, all those apps use protocols like HTTP and SMTP to talk to the network.
So if we've checked everything else and the website's still giving us trouble, the problem might be with the website itself or the protocols it's using.
You got it. Could be a server issue, a firewall, even a problem with the website's code.
Wow, what a trip through the OSI layers. It's like a whole roadmap for troubleshooting.
It is. And even though most of us won't use OSI for everyday troubleshooting, knowing how it works gives you a much deeper understanding of what's going on behind the scenes when you're online.
Okay, so we've established OSI is handy for understanding how networks work and for troubleshooting. But how did this whole 7-layer system come about? Why 7? Why not 5 or 10?
That's a great question, and it gets to the heart of why the OSI model is so powerful. The 7 layers were chosen because they each represent a specific function in network communication.
Okay, let's break them down, starting from the bottom, the physical layer. What's happening down there in the depths of OSI?
Down there, it's all about the physical stuff. Cables, connectors, Wi-Fi signals, and data getting transmitted as bits, those ones and zeros that computers use.
So like the foundation of a house, the physical structure, everything else is built on.
Exactly. It defines things like what kind of cable you're using, the voltage for electrical signals, data rates for speed, even the shape of the connectors.
So it's taking those abstract bits and translating them into the real world. What happens once those bits are flowing through the wires?
That's where the data link layer steps in. Think of it like a quality control check, making sure data is transmitted correctly within a local network.
Like making sure the message doesn't get garbled on its way. How does it do that?
A couple ways. First, it divides the data into frames, kind of like envelopes for data packets. Each frame has header info, like an address on an envelope.
So it's adding some structure to raw bits. What else?
This is where those MASI addresses we talked about earlier come in. The data link layer uses them to make sure data frames get to the right destination on the local network.
Like making sure the mail gets delivered to the right apartment. Okay, so the data link layer keeps things running smoothly on the local network. But what happens when data needs to go beyond that?
That's when the network layer kicks in. This is where we start talking about routing, finding the best path for data to travel across different networks to get where it needs to go.
So it's like planning a cross-country road trip, figuring out the best highways to take.
Exactly. The network layer uses IP addresses, kind of like global addresses for devices on the internet, to figure out the best path for data packets, like zip codes for the internet.
Okay, now those IP addresses sound familiar. So the network layer plans the big picture, the global route. Then what?
Then it's the transport layer's turn. This layer is all about making sure data gets delivered reliably between applications, like making sure your package gets to the right address, in one piece, and in the right order.
It's not just about getting it there. It's about getting it there in good condition. How does it pull that off?
It uses some clever tricks. First, it chops up the data into smaller packets, easier to handle. Each packet gets a number so they can be put back together in the right order at the destination.
Like breaking down a big shipment into smaller boxes, each with a label telling you where it goes in the whole thing.
Exactly. And the transport layer also does flow control, making sure one device isn't sending data faster than the other can receive it, like making sure there's room at the receiving end before you send everything over at once.
So preventing data traffic jams, basically. I know there's some protocols that work at this layer, right? TCP and UDP.
You got it. Those are the big two. TCP, or Transmission Control Protocol, is the reliable one. It guarantees delivery, ensures things arrive in order, and can even resend lost packets. UDP, or User Datagram Protocol, is faster but less reliable. It's used for things like video streaming, where a few dropped packets won't ruin the experience.
So TCP is your meticulous courier service, and UDP is more like sending a letter and hoping for the best. Okay, I'm really starting to see how this all fits together. So our data is packaged, sequenced, and moving along smoothly. What's next in the OSI hierarchy?
Next up is the session layer. This one's all about managing the actual communication session between devices, making sure things are coordinated and running efficiently.
So it's like the stage manager of a play, making sure all the actors are in place and the scenes flow smoothly.
I like that analogy. It handles authentication, making sure the right devices are talking, and synchronization, keeping both devices on the same page during data transfer.
So it's setting up a structured communication session, not just sending data blindly. What happens at the presentation layer?
The presentation layer makes sure the data is understandable to the application. It's like a translator, converting data from one format to another so different systems can understand each other.
Like translating a book so everyone can read it no matter what language they speak.
Precisely. It also handles encryption and decryption to keep sensitive information safe during transmission. And it takes care of data compression, shrinking things down so they can be transferred more efficiently.
Adding security and efficiency to the mix. And finally, the top floor, the application layer. This is where we actually use the network, right?
Yep, that's where you interact with all those apps that use the network, browsing websites, sending emails, streaming videos, all that good stuff.
So it's the layer we see and use every day. But it's not the applications themselves, right? It's more about how they communicate.
Exactly. It's about the protocols they use. For example, your web browser uses the HTTP protocol, which lives in the application layer, to talk to web servers and fetch web pages.
Okay, so it's providing the communication channels for all those apps to do their thing. So we've gone through all 7 layers of the OSI model, from the physical transmission of bits all the way up to us using our apps. It's way more intricate than I thought.
It's a beautifully designed model, even if it's not running the internet directly today. But understanding OSI gives you a framework for understanding how networks work. It's like having X-ray vision for the digital world.
I'm definitely feeling more enlightened about networking after this, but now I'm curious, if the OSI model is so well designed, why isn't it the dominant model for the internet?
That's a great question, and it takes us to the story of how the internet evolved. You see, while OSI was being developed, another model was already gaining traction, the TCP/IP model.
Ah, so it was a bit of a standards war, kind of like Betamax versus VHS back in the day.
You got it. And in this case, TCP/IP came out on top. But that doesn't mean OSI is useless. It still provides a valuable framework, and there's even some overlap between the two.
Okay, I'm definitely ready to hear more about this TCP/IP model. How is it different from OSI, and why did it become the internet's go-to model? Okay, so last we left off, TCP/IP was making its move. What's the story there?
Well, as the internet was really taking shape, TCP/IP was already being put to use and proving it could handle the job. It was simpler, more practical, and really importantly, it was open and could adapt so people could innovate quickly.
So while OSI was going for perfection, TCP/IP was getting things done, kind of a tortoise and hare situation.
I like that, yeah. OSI with its 7 layers, it was thorough, well-organized, but maybe a bit too much for the fast-paced world of the internet. TCP/IP, on the other hand, was more nimble, easier to actually implement with its 4 layers.
4 instead of 7. Huh. That does sound a bit easier to wrap your head around. But before we compare them head-to-head, break down these 4 layers of TCP/IP for me. Where does it all begin?
At the very bottom, we've got the network access layer. This layer takes care of the physical connection to the network, like your Ethernet cable or Wi-Fi signal, and it handles transmitting those data frames.
So it's like combining the physical and data link layers from OSI.
Right. Think of it as the nuts and bolts of getting data onto the network.
Okay, so local network communication. What's next as we move up the TCP/IP ladder?
Next, we got the internet layer. This is where IP addresses come in and those routing protocols that figure out the best path for data to travel across different networks.
Ah, so this is where the global addressing and routing happens. Similar to the network layer in OSI. What about the transport layer in TCP/IP? What's it responsible for?
Same as in OSI, the transport layer here is all about reliable data delivery between applications, making sure the data shows up in the right order, managing that flow control, and doing error checking.
And this is where we find those trusty protocols, TCP and UDP.
You know it. TCP, with its guaranteed delivery and error correction, is the go-to for applications that need reliability above all else. UDP, well, it's all about speed. It's great for streaming videos and games where a dropped packet here and there won't ruin things.
So TCP is the meticulous delivery service, and UDP is sending a postcard and hoping for the best. All right, what about the final layer in TCP/IP?
At the top of the stack, we have the application layer, and this is where TCP/IP does things a bit differently from OSI. It combines what OSI does in 3 layers: session, presentation, and application, all into one.
Whoa, that's a lot to handle for one layer.
It is, but that streamlining is part of what makes TCP/IP so efficient. The application layer takes care of everything related to setting up, managing, and closing connections. Formatting data for different applications, providing services to those apps, the whole 9 yards.
Like a one-stop shop for application communication needs.
Exactly. It's where you find protocols like HTTP for web browsing, SMTP for email, FTP for transferring files, and many others.
Okay, so this streamlined 4-layer model handles everything from the physical connection to how apps talk to each other. Sounds impressive, but I still want to know why TCP/IP won out over OSI. Was it just because it's simpler?
Simplicity definitely helped, but TCP/IP was also more flexible, it could adapt more easily, and that was crucial in the early days of the internet when things were changing so fast. It was open, readily available, which meant people could collaborate and experiment more easily.
It was a more open, collaborative approach, kind of like the internet itself.
You got it. And that openness allowed TCP/IP to evolve and keep up with the changing needs of the internet. OSI, well, it might have been a bit too rigid to keep pace.
It's interesting how these two models, developed around the same time, ended up going in such different directions. So TCP/IP became the king of the internet. Does that mean OSI is just a relic of the past?
Not at all. Even though TCP/IP is what makes the internet work, OSI is still really valuable for understanding the principles behind networking. It's a great way to think about how networks function, and it's still widely used in education and training.
So it's like learning Latin to understand the roots of language, even though we don't speak Latin in everyday life anymore.
Perfect analogy. OSI gives you that foundation, that deeper understanding of how it all works.
Okay, I'm definitely convinced that OSI is worth learning, even though it's not running the internet directly. But all this talk about layers and protocols, it's a lot to take in. Can we maybe try to picture how it all works in action?
Definitely. Let's use email as an example. We can walk through how data flows through the OSI layers when you send an email.
Perfect. Let's say I want to send an email to my friend, Mrs. Palmer. Where does the journey begin?
It all starts at the top, the application layer. You open your email program, write your message, and hit send. Your email program uses a protocol called SMTP, that's Simple Mail Transfer Protocol, to prepare the email for its journey.
So the application layer is like the post office counter where you drop off your letter.
Good way to think about it. The application layer gets that email packaged up and ready to go.
Okay, the email is ready. What happens next as it travels down through the OSI layers?
Next, it hits the presentation layer. This is where the email data gets formatted and prepared for transmission. Could be encrypting the message to keep it secure, compressing it to make it smaller, or translating it into a standard format so the receiving system can understand it.
So it's making sure the letter is properly addressed and has the right stamps.
Exactly. The presentation layer gets that data ready to go and ensures the recipient system can read it.
Okay, letter's prepped and ready for delivery. What happens next?
Now it's down to the session layer. This is where a connection is set up between your computer and Mrs. Palmer's, creating a channel just for this email.
So it's like picking up the phone and dialing her number to make sure the line is open before you start talking.
Precisely. The session layer makes sure the communication session between the two devices is all set.
Okay, the connection is made, the email is all ready to go. What does the transport layer do?
The transport layer's job is to ensure that data gets delivered reliably. It breaks the email into smaller segments and adds headers with info about the order and any error checking. This is where TCP comes in, making sure all those segments reach the destination in the right order and without any mistakes.
Like taking a big package and dividing it into smaller boxes, each with a tracking number, so you can put it back together on the other side.
Great way to think about it. The transport layer makes sure the email arrives safely and in one piece.
Okay, we got these email segments all packed up and ready to travel across the internet. What role does the network layer play in all of this?
The network layer is the master planner. It figures out the best path for those email segments to travel across the networks that connect your computer to Mrs. Palmer's.
Like mapping out a road trip, finding the best route to avoid traffic and delays.
Exactly. The network layer uses those IP addresses, those global addresses for devices, to make sure things go to the right place.
So from global routing to local delivery, it's all coming together. And finally, the physical layer, the actual sending of the signal.
Right. The physical layer takes the data, converts it into electrical signals or light pulses, and transmits it through the physical medium. Could be copper wires, fiber optic cables, or Wi-Fi.
Wow, what a journey. We followed that email all the way from the application layer down to the physical layer where it's sent out into the vast internet. But it's not over yet, right? Now those bits have to travel back up the OSI model on Mrs. Palmer's end.
Exactly. The whole process happens in reverse on the receiving end. Mrs. Palmer's computer picks up the signals at the physical layer and converts them back into bits. The data link layer rebuilds the packets, strips off the MAC address info. The network layer checks the IP address, knows it's reached its destination. And the transport layer puts all those segments back together, reconstructing the original email.
Like unwrapping a present, revealing the original message.
And as we move up, the session layer confirms everything arrived okay and closes the connection. The presentation layer removes any compression or decryption that was applied earlier.
And finally, at the application layer, Mrs. Palmer's email program gets the message and puts it in her inbox, ready to be read.
Exactly. And that's how an email travels the internet, all thanks to the structured framework of the OSI model.
Okay, I had no idea that much was going on behind the scenes every time I sent an email. Yeah. It's like a whole microscopic world of activity.
It is. And this is just one example, remember. The OSI model applies to all sorts of network communication. Web browsing, streaming videos, online gaming, everything.
So even though the internet today isn't actually running directly on the OSI model, understanding those 7 layers helps us grasp just how complex and intricate this whole process is.
Absolutely. It gives you that deeper understanding of how it all works, how data gets from one place to another.
This deep dive has been incredibly insightful. I feel like I have a whole new perspective on the internet now.
That's great to hear. And this is just the beginning. There's a whole world of networking out there to explore.
Speaking of exploring, is there a final thought you'd like to leave our listeners with?
I'd say think about the future of communication. Imagine we're designing something brand new, something beyond the internet as we know it today. How could the principles of the OSI model guide us? How could we use it to create something efficient, reliable, and interoperable?
That's a great question to ponder. It shows just how relevant the OSI model still is, even with all these new technologies emerging. All right, this has been an awesome deep dive. A huge thanks to you, our expert, for walking us through the OSI model and TCP/IP.
Happy to do it. And to our listener, keep in mind there's always more to learn in this vast world of networking. Keep exploring, keep asking questions, and keep diving deep.
And we'll be here to guide you along the way. Until next time, happy networking. All right, so my brain is officially overflowing with networking knowledge now, but I do have one more question about the OSI model itself. We talk about how it's got these 7 distinct layers, each with its own job. Why 7, though? Did they just pull that number out of a hat, or is there a reason behind it?
Oh, there's definitely a reason. They didn't just pick 7 randomly. It's all about taking a modular approach to network communication, breaking down a really complex process into smaller, more manageable pieces.
Okay, so it's like divide and conquer for networking. But why 7 specifically? Why not 5 layers or 10?
The folks who designed the OSI model, they really thought about all the different things that need to happen for networks to work. They landed on 7 layers as, like, the sweet spot.
Right.
Enough detail to be useful, but not so much that it gets overwhelming. Each layer has a clear purpose, and they all build on each other logically.
Okay, so this layered approach is key. But what does that actually mean for the real world? Why is this modularity so important?
Imagine you're trying to build a house, right? And you don't have different teams for the different jobs, like electricians, plumbers, carpenters. It would be a total disaster.
Yeah, a complete nightmare. So you're saying the OSI model is like assigning those different tasks to specialized teams so everyone can focus on their expertise and things get done more efficiently.
That's a great way to put it. Each layer can just worry about its own tasks without getting bogged down in what the other layers are doing.
Okay, that makes sense for keeping things organized and efficient. But how does this modularity help us, the people actually using the internet?
Well, one big advantage is interoperability. That means devices made by different companies can all talk to each other without any problems.
Oh, so it's like having universal adapters for all our gadgets.
Exactly. Everyone can understand each other no matter what brand or operating system they're using. That's super important for the internet to work as a global network. Another advantage is flexibility. If you need to update or change something, you only have to tweak the layer that's involved. You don't have to mess with the entire system.
So it's like switching out a light switch without rewiring the whole house.
Exactly. You can adapt to new technologies and standards much more easily that way.
All right, I'm sold on the layered approach, but I'm still curious about the number 7. Is there something special about that number, or was it just a coincidence?
Well, there's no magic to the number 7 itself. But the designers of the OSI model, they did have their reasons for choosing 7 layers. They wanted to find a balance. Enough detail to be comprehensive, but not so much that it becomes too complicated.
So not too many, not too few, just right.
You got it. They analyzed everything that goes into network communication and figured out that 7 layers hit that sweet spot.
So they were aiming for the Goldilocks zone of network layering. But it's kind of mind-blowing that this super well-designed model isn't actually what the internet uses today. If it's so great, why didn't it become the standard?
It's a good question, and it shows that technology doesn't always evolve in a neat and tidy way. While they were working on the OSI model, another model, TCP/IP, was already gaining popularity.
So it was like a battle of the models.
Kind of. And in the end, TCP/IP, with its 4-layer structure and more practical approach, won out. It was already being used, showing it could get the job done, while the OSI model was still being developed.
So TCP/IP was the underdog that came out on top. Sometimes being first and functional is more important than being perfect.
Absolutely. In the fast-paced world of tech, being able to move quickly and adapt is super important.
Well, this has been a truly eye-opening deep dive. I feel like I've gained a whole new understanding of how networking works. It's amazing.
I'm glad to hear that. And remember, even though the internet doesn't use the OSI model directly, its principles and concepts are still incredibly valuable.
It's like a wise old mentor that still has a lot to teach us, even if we've moved on to newer things.
I love that analogy. The OSI model provides a foundation for understanding the core principles of networking, which is essential in today's digital world.
Okay, I'm definitely going to keep that in mind as I continue exploring the world of tech.
Okay.
Any last words of wisdom for our listeners before we wrap things up?
The internet is constantly evolving, with new technologies popping up all the time. But those fundamental principles of networking, the ones we've been talking about today, those remain constant. Understanding those will help you navigate the digital world no matter what new advancements come along.
That's fantastic advice. A huge thank you to you, our expert, for leading us through this fascinating journey into the world of networking.
It's been a pleasure. And to all our listeners out there, always remember there's a whole universe of knowledge out there to explore. Keep learning, keep asking questions, and keep diving deep.
And we'll be here to join you on that journey. Until next time, happy networking, everyone.